In the last video, we learned about neurons, weights, and how AI learns from mistakes. Now let's see what happens when you connect those neurons together. This is the story of neural networks, from a single neuron all the way to deep learning. It all started in 1958, when a scientist named Frank Rosenblatt invented the perceptron. It was just a single artificial neuron. Think of it as the simplest possible decision maker. It takes in some inputs, multiplies each by a weight, adds them up, and gives you a yes or no answer. Is this email spam or not? Is this picture bright or dark? A perceptron can only draw a straight line to separate two groups. If your data can be split with a straight line, great. The perceptron works. But what about problems where you need a curved line? A wavy boundary? A single perceptron can't do that. This was a big limitation, and for years, people thought neural networks were a dead end. The breakthrough came when people realized, what if we stack multiple layers of neurons together? Instead of one neuron making the final decision, we have layers of neurons, each passing their output to the next layer. The first layer might detect simple patterns, like edges or basic shapes. The second layer combines those simple patterns into more complex ones. And the final layer makes the actual decision. Think of it like an assembly line in a factory. The first worker cuts raw material. The second worker shapes it. The third worker paints it. The final worker inspects and approves. Each layer adds more sophistication. This is called a multi-layer perceptron, or MLP. The layers between the input and output are called hidden layers, because you don't directly see what they're doing. And here's the magic, with enough hidden layers and neurons, this network can learn incredibly complex patterns, not just straight lines. Now let's talk about activation functions, because they're the secret sauce that makes neural networks powerful. Without an activation function, no matter how many layers you stack, the network is just doing simple multiplication and addition. It can only learn straight lines. Activation functions add curves. They add nonlinearity. Think of it like cooking. Adding ingredients is linear. But cooking transforms them into something entirely different. The activation function is the cooking. The most popular one today is called ReLU. It's dead simple: if the number is positive, keep it. If it's negative, make it 0. That's it. But this simple rule lets the network learn incredibly complex patterns. For the output layer, we often use Softmax, which converts the outputs into probabilities that add up to 100%. So the network might say, 80% chance it's a cat, 20% chance it's a dog. Now let's talk about what deep really means in deep learning. A neural network with just one or two hidden layers is called a shallow network. Deep learning simply means using many hidden layers. Sometimes dozens. Sometimes hundreds. Why does depth matter? Because each layer learns to represent the data at a higher level of abstraction. In an image recognition network, the first layer might detect edges, lines, and corners. The next layers combine those into textures and shapes. The deeper layers recognize parts like eyes, noses, and wheels. And the final layers put it all together to say, that's a face, that's a car. More layers means the network can understand more complex relationships. But there's a catch. The deeper the network, the harder it is to train. Gradients can vanish or explode as they travel back through many layers. Solving this problem is what unlocked the deep learning revolution. So that's neural networks. From a single perceptron that could only draw straight lines, to deep networks with hundreds of layers that can recognize faces, understand language, and beat humans at complex games. But here's the thing, a standard neural network treats all inputs the same way. It doesn't understand that pixels next to each other are related, or that words in a sentence come in a specific order. To handle images, we need something special. That's where convolutional neural networks come in. That's our next video.